Good day everyone. I'm going to tackle about rectilinear motion with variable acceleration. So when will we use variable acceleration? We will use variable acceleration when the acceleration is not constant. And here are some tips to determine if it is variable acceleration. When bodies are acted upon variable forces, they move with variable acceleration. Second is to determine the kinetic equations of motion. In such cases, it is necessary to apply the given data to differential equations of kinematics. Third one is, since acceleration may vary in many ways, no general equations can be stated as was done in the case of constant acceleration. As we go back in the constant acceleration, we have three formulas or three equations or three formulas, which is V final equals V initial plus acceleration times time. And the next one is V final squared equals V initial squared plus 2 times acceleration times displacement or distance. And the last one is distance equals V initial times time plus 1/2 AT squared. So here in variable acceleration, we can't use this formula because as we go back in our discussion, since acceleration may vary in many ways, so no general equations can be stated as was done in the case of constant acceleration. At most, we can only indicate the procedure to be followed. The third one is basically we have three principal variables. S equals displacement or distance, while V equals velocity or speed, and the last one A is equals to acceleration. It is related by a common parameter t. The fourth one is each of the principal variables may be expressed in terms of the time, or they may be expressed in terms of each other, or even a combination of others. So, let us consider here the simpler combination. We were going to consider the simpler combination, so I'm giving this three case so that you can solve it directly or in easy way. Case number 1. The displacement is given in terms of time. Displacement equals function of time. So to find velocity and acceleration, we must use this formula, which is velocity equals displacement with respect to time. So we have a given that is displacement. So to determine the velocity, we must use velocity equals displacement with respect to time. Velocity equals displacement with respect to time. So the given is displacement. We must substitute this displacement to this given equation. To find acceleration, we must substitute what we get in our first derivatives and derive it, or we must get the velocity When we get the velocity, we must input or substitute it here, which is acceleration equals derivatives of velocity over or with respect to time. And case number 2. The acceleration is expressed in terms of time. A equals function of time. To find velocity and displacement, we're going to use this formula. A equals derivatives of velocity with respect to time and cross multiply it, and we will get this dv equals a dt, and we must input the acceleration equals function of time here, which is we're going to integrate both sides so we can get the velocity. Velocity equals integral of acceleration times acceleration with respect to time. So we were given acceleration equals function of time, so we must input acceleration function of time, which is we were going to get this and the last, and to get the displacement, case number 3. The velocity is given in terms of the time. Velocity equals function of time. So to find acceleration and displacement, we will use acceleration equals derivatives of velocity over with respect to time, and we will input the function of t and here, so we will get this acceleration equals function of t over with respect to time. So the next one is to find the displacement or s. We will use the formula velocity equals ds or displacement over dt, and we must cross multiply this, so we will get ds equals dt v dt,